Hello, Mr. Eric, Mr. Ryan, are you right?
Yeah.
Okay, so let's look at this problem. Partition an array into pairs, and the sum of each pair needs to be divisible by k. So we have this array, all positive numbers. K is also a positive number. So 4, 2, 8, 1. So we want to partition in a pair. A pair is two numbers, yeah? Can we partition this array into pairs so that each pair, the sum of each pair is divisible by 3? Anybody?
4, 2, 8, 1.
4, 2 or 8, 1 or 4, 8, 2, 1. Both are okay. So for example, like 4, 2, 8, 1, 4 plus 2 divided by k is 0, k is 3. And a plus 1 divided by k equal 0. Okay? Come on. We also 4 plus a or 2 plus 1 is both okay. Okay. If two numbers a and b need the sum of a and b needs to be divided by k. Yeah, we divide it as modulus equal 0. It also means that a plus b is the multiple of k. Yeah, it's k times something. Yeah, k times something. Okay, so that's how we check if the sum can be divisible by k. Okay, so in mathematics we have these three lines. Two lines equal. Three lines is called congruence modular. Okay, so a congruence is congruence to b modulus n. Okay, so let's take an example. 24 is congruence to 36 mod 12. What does it mean? It means that 24 divided by 12 remaining 0. 36 divided by 12 remaining 0. It's the same thing. A congruence 10 modulus 2, right? Because they both even numbers. A divided by 2 remains 0. 10 divided by 2 remains 0. How about modulus 3 divided by 3 remain 2. 11 divided by 3 remain 2. Okay? So that's what the congruence modular is. Okay, so coming back to this question, we want to look for a plus b modulus k equals 0. So we can rewrite this as a plus a modulus k plus b modulus k equals k modulus k, okay? Then we can rewrite this into a modulus k equals k minus b modulus k. Okay, so look, a and k minus b is a pair. Okay, so for example, if this number is 4, 4 modulus 3 equals 1, right? So it has remained 1. So look, 4, it has remained 1. So the other number, for example, a, 1, 2, 3, 4, 5, 6, 7, 8, okay? It has 2 extra, right? 2 extra. What does it mean? A modulus k, a modulus 3 remains 2. It has 2 extra. It has 2 extra. So this group has 2 extra. This group has 1 extra. So we have 1 more here, and we have 2 more here. So put it together, 1 plus 2 is a multiple of k, right? So coming back to this question, so we can use the dictionary hash map to store what? If the number is I, we can store the k, I modulus k to store the remain k, right? We can partition arrays only if we have pairs in each remainder. For example, like for the remainder 1, we have 4. For the remainder 2, we have 8. 2, these two numbers also remain 2. This 1 also remain 1. Look, we have 2 numbers in the remainder 1. We have 2 numbers in the remainder 2. So we can pair. So we can pair 4 plus 2, or we can pair 4 plus 8. We can pair 1 plus 8, or we can pair 1 plus 2. Get it? So it has to be an equal number of numbers in each pool. So each pool is the remainder, yeah? Remainder pool, yeah? Got it?
Yeah.
Okay. So define partition k divisible number. Yeah, nums k. So if the number of elements in the array is odd number, can we pair? Can we pair? No. Why is that?
Because odd numbers can't divide.
That's right. Because for example, if I give you 5 numbers, can you form them in pair? No, because there's always 1 extra, right? Yeah.
1, 2, 3, 4, and then.
Wow.
There we go.
What's this?
Half of 5.
I see. Okay, come on.
See?
Okay. Got it. Okay, that's great. So first of all, n equals the length of numbers. So this has to be an even number. If it's an odd number, if it's a low number, we return false. Easy. Then we store the I plus k, I modulus k in the dictionary. So we use the s, for example. S equals default dictionary. The default type is int. By default, the int type gives the value, default value, 0 when the key is not existent. Okay, then we go through this number for I in nums, and then s I modulus k plus equal 1. Okay, so we are incrementing, we are storing the frequency. Remember the pool 4a to 1 and k equals 3. So what we are doing is that when s equal I modulus k equals 1, then there will be 4 and 1. So S1 is 2 in this case. And then the remainder 2 is 2, A and 2. And then S2 is also 2, right? Two numbers here. We have to consider the special case when the remainder is 0, right? If S0 is an odd number, we still need to return false, right? For example, like if we have k equals 3, and then number is 3, 6, 9, right? So these numbers itself can be divisible by k, so we need even number of it, right? Because it can't, so these numbers have its own group, 3, 6, 9, right? If they are odd number of the numbers here, right? So what happens? So it can't find a pair. It doesn't have its pair, okay? It doesn't have its pair.
Yeah.
So we need to return false. Otherwise, we just have to check. The remainder I needs to pair with k minus I. Then we return false.
Are you okay?
Return false. Otherwise, if we can't find anything here, then return true. So this whole thing, this number of lines can also be rewritten as return all Si equal Sik minus I for I in range 1k. So the time complexity is On. The space complexity is On because we are using we're using the default dictionary. The number, we go through the numbers, yeah, once, right? We can use another way to write it quite simple. Okay, so the idea is that when we find the numbers, we can just increment the counter, right? And if we don't find this number in a pair, we just decrement it, right? F equals default dictionary int, okay, and then we C equals 0, okay? And then we just go through this number for I in numbers, and then we just say A is the number I divided by K, B is the other number in the pair, so which is K minus A divided by K, and then if FA is bigger than 0, then we just decrement it. Fa minus equals 1, C minus equals 1, else Fb plus equals 1, C plus equals 1, and at the end we just have to check if return C equals 0. Okay? So that's why I say A and B is two numbers in a pair. If Fa frequency bigger than 0, we have the numbers in the pair, then we decrement it, we decrement counter. Otherwise we increment it. Okay, so at the end the numbers needs to come in the pairs. This is On time because look, we go through these numbers and we use the dictionary, so that's On space as well. Okay, so to sum up, what have you learned today?
Partition list to pair that are divisible by k.
So we have an array of numbers. The array contains all positive numbers, yeah? And we want to partition. We want to find out if we can partition the numbers into pairs, and the sum of each pair needs to be divided by k, right? Divided by k. And then what are we doing here is we use a dictionary to store the remainder by k. Divide by k remainder, right? For example, k is 3. If the number divided by k remain 2, and the number needs to be paired with the number which divided by k remain 1, because 2 plus 1 is a multiple of k, right? Okay, that's it for today. Bye bye.
Bye.